In the lecture today, we will further go through some fundamental two-dimensional joining skills, including circles, arcs, ellipses, rectangles, donuts, and some operations about points. First, let's go through the joining of circles in AutoCAD. Actually, circle might be one of the most common components in two-dimensional joinings. The command for you to join a circle is just a circle. You can also go to the toolbar Joining and select Circle icon to build a new circle. In AutoCAD, there are 5 different methods for you to generate a circle. The first one is center plus radius or diameter. You can also use 3 points, 2 points, tangent, tangent, radius, tangent, tangent, tangent to generate a new circle. In the next couple slides, I will show you how to use all these methods and one example about the implementation of circles. Here I will show you how to generate a circle with different methods in AutoCAD. In AutoCAD, you can either use the circle icon in the toolbar or type the command circle in the command window to start the joining of a new circle. The default method is the center plus radius. So first you have to specify the center and then you have to type the value for the radius. I said the value is 10 units. Now you generate a new circle with a radius of 10 units. The second method is a center plus diameter. So here you need to specify the center of the circle again. And next you have to specify the value of the diameter. So choose the option here, define the value of the diameter as 16 units. Now you will build a smaller circle with a diameter of 16 units. The third method is 2 points, which will define the ends of the diameter and use that one to identify a circle on the screen. So that's the third method. And the fourth method is the 3 points. In this method, you will identify any 3 points in one circle and use that 3 points to identify one circle on the screen. So that's how you will build a circle with 3 points. And the fifth method is a tangent-tangent radius. This one is quite useful. And you can define a circle which will be tangent to the other two objects. It's not necessary to be circles. It could be line, arcs, and ellipse. And then you specify the radius of that circle. This one will give you one identical circle on the screen. So choose this method, select the first object, second object, and then define the radius, say as 10, 15. And now you will generate a new circle which will be tangent to these two smaller circles and with a radius of 15. The last method, which is also very useful, is called a tangent-tangent-tangent. This one will create a circle tangent to 3 different objects. Could be in a circle, arc, or in a straight line. So here you can select first object, second object, and third object. And then a circle will be generated automatically and the tangent to all these 3 selected objects. So that's all about the generation of the circle with different methods. Next, I will show you how to complete this example with a different method for the circle in AutoCAD. To complete the example here, we need the help of some assistant lines. We will first draw a horizontal line to connect the centers of these 2 circles. So use the line command and choose the orthogonal mode to draw a horizontal line with the length of 60 units. And then the left end would be the center of the smaller circle and the right end would be the center of the larger circle. And the diameter of this circle is 40, the diameter of this one is 60. So we use the circle command, choose the central diameter. Select the center and type the diameter as 40 units. And then do it again for the larger circle. Select the center, and the diameter would be 60 units. And then for this circle, it should be tangent to both circles, and the diameter of this one is also 40 units. So we have to use the option tangent radius and choose this one as the first object, this one as second object, and then you have to specify the radius because the diameter is 40 units, so the radius shall be 20 units. And this one gives you the third circle. And then for the last circle, we know that this circle should be tangent to this one and the second circle, and if we join a horizontal line about 40 units below, then it should also be tangent to the horizontal line. So we have to call the construction line X line and choose the offset, specify the offset distance as 40 units, and then choose this one as the line object and find out the offset line. And then next, you have to use the option tangent to complete the last circle. Choose the first object, second object, and third object. Then the circle will be completed automatically. Now last, you remove these two reference lines, and we complete the joining. In two-dimensional joining, sometimes we are only interested in one part of the circle, which means we only want to input an arc in the joining. In AutoCAD, the command for you to generate an arc is just an arc, and you can also go to Toolbar, choose Joining, and select Arc icon to build a new arc. Also, there are many different methods for you to generate an arc precisely. The default method is 3 points, which means you can identify any 3 points on the screen to define the arc. There are also some other centering methods, such as the angle, chord length, arc start and end points, arc start point plus length to define the arc precisely. In the next slides, I'm going to show you how to use this method and how to use arc in one example. There are many different methods to generate an arc in AutoCAD. Generally, you can choose the icon in Toolbar to start the joining of the arc, or you can type the arc command in the command window. The default method is 3 points. You can specify the start point, the second point, and the end point to define a new arc. The second method is called the start center end. With that one, you can specify the start point and then define the center of the arc. At last, you can specify the end of the arc. The default direction for the arc is counterclockwise. If you want to switch it back to clockwise, hold Ctrl, and then the arc will be clockwise. The third method, the start center angle. So you can define the start point, the center, and then you can specify the angle to define the arc. For example, if I set the angle as 90 degrees, now you define the arc counterclockwise with the angle of 90 degrees. And also you have all the other methods. For example, you can specify the arc based on the start center and the chord length. So use the start point, center, and then you can specify the chord length to identify the arc. So those are 4 most common methods to define the arc. Next, I will show you how to use the arc command to complete the figure here. To complete this joining, we will need the help of 2 horizontal lines to identify the radius of these 2 arcs. So we will first need the help of the orthogonal mode. So activate the orthogonal mode and choose the line command to draw the first line segment with length of 30 units. And then we have to draw another line with a length of 60 units. And exit the line command. Next, we will draw these 2 arcs. We know that for this arc, the start point would be the end of this short line segment, and the radius is 60 units, and the angle of this arc is 40 degrees. So we can choose the option Start, Center, and Angle to identify this arc. Click here and identify the end as the start point, this end as the center, and then you can draw the arc. We know that the arc is defined counterclockwise, so you have to press Ctrl to make it clockwise. And also, the angle of the arc is measured counterclockwise, so 40 degree becomes 320 degree. So that's the way for you to generate the first arc. You can also use the similar method to generate the second arc. Choose this one as a start point. This is the end point, and press hold and type the angle as 320 degree. And that's the way for you to generate the second arc, and then use line command to connect these two ends. The last thing would be the generation of this arc. Here we know the start and end point of the arc and also the radius of the arc. So we can use the option Start, End, and Radius to define this arc. So choose the start point here, the end point here, and similarly you have to hold Control to make it clockwise and type the radius as 35. And that's the way for you to complete this figure and then delete this assistant line. You will done the whole figure. AutoCAD also provides one command to generate the ellipse. The command is ellipse, and you can also find out the ellipse icon from the toolbar. Basically, there are two methods for you to generate an ellipse, axis and center. Both methods will identify the dimension and directions on the axis for one ellipse. Also, this command provides one function for you to pick up one part of the ellipse. So that will generate an ellipse arc. You can use the angle to define that arc. In the next slide, I'm going to show you how to use the ellipse command. Here, I will first show how to draw a full ellipse in AutoCAD. You can either use the icon in the toolbar or type the command ellipse to build a new ellipse. The default method is the axis method. You will be asked to identify the direction and the dimension of the major axis. Then you have to specify the length of the minor axis. That one gives you the definition of the ellipse. And you can also use the centering method. Choose the center option here, define the center of the ellipse, and then you can identify the direction and the length of the major axis, and define the length of the minor axis. That one gives you another full ellipse. The third issue related to this command is ellipse arc. If you choose the arc option, it will be asked to generate an ellipse arc. The first step is to define a full ellipse, which will be similar to all the previous two methods. And then, once you complete the ellipse, you can specify the start location of the arc and then the end location of the arc. Then you complete the definition of the ellipse arc. That's all operations about the ellipse in AutoCAD. The next command we will learn is a donut. This command will generate two circles with the same center, and the region between these two circles is filled with a certain color. You can also go to the toolbar, find joining and the donut icon to generate a new donut. There's only one way for us to define a donut. First, you have to identify the inside diameter, and then you have to specify the outside diameter. Finally, you need to use your cursor or the coordinates to identify the center of the donut so that you can input one donut on the joining. Next, I'm going to show you how to define a donut in AutoCAD. To generate a donut in AutoCAD, you can go to the toolbar and select the donut icon, or you can just type the donut command in the command window directly. And first, you need to specify the inside diameter of the donut, say it's 5 units, and then you have to enter the outside diameter, say it's 10 units. Next, you can type the coordinates for the center, or you can just use your cursor to place the donuts on the screen. In this command, you can actually insert multiple donuts at one time. Once you complete inputting the donuts, just press enter to exit the command. Rectangle is another commonly applied component in two-dimensional drawings. In AutoCAD, the command for you to insert a rectangle is a rectangle or just simply rec. You can also go to the toolbar, select Joining, and find out the rectangle icon to insert one rectangle. This command also provides several options for you to modify the property of the rectangle, including chamfer, elevation, fillet, thickness, and width. In the next slide, I'm going to show you how to generate a rectangle and how to modify the property of the rectangle. It's actually very simple to define the rectangle in AutoCAD. You can go to the toolbar, select the rectangle icon, or you can just type the command rec to activate the operation. The default method to define the rectangle is 2 points. In this method, you can first identify one corner and then specify the other corner to define one rectangle. The second method for the definition can be based on the area of the rectangle. Still, you need to define one corner of the rectangle and then choose the option area if you want to define the area of the rectangle as 200 square units. Then next thing you need to specify is the value of the length or the value of the width. So if we choose the value of the length, you need to identify the value. We say the value is 40 units. And then we will generate a rectangle with the length of 40 units and the width of 5 units for the total area of 200 square units. The third method is define the dimension directly. So this one is really helpful for you to identify one rectangle with specific dimensions. Still, you have to identify the location of the rectangle first, and then choose the dimension option. Now you have to specify the dimension for the length, say it's 20, and then you have to identify the value of the width, say it's 10. And then you can generate one rectangle. Use your cursor to identify the correct location for that rectangle. And here you will also see that there's one option for you to define the rectangle, which is called the rotation. In that sense, you can actually rotate the rectangle a little bit. The angle is a counterclock angle respect to the positive x-axis. Once you specify that angle, you can identify the rotated rectangle on the screen. Now let's go to see how to modify the property of one rectangle. Here, once you type the command rec, you will see several options: chamfer, elevation, fillet, thickness, and width. The elevation and thickness are actually related to three-dimensional drawings, so we will leave these two options for the chapter 5, and we will only talk about the rest two options. First, for chamfer option, this kind of function is actually used to smooth the corner of the rectangle. You will use a straight line to smooth that corner. So here you have to define the displacement on the two lines related to that corner. For the first chamfer distance, let's say it's 2 units, and for the second one, say it's 4 units. Then let's go to see the effect of this setting. And here you will see that the corner of the rectangle is smooth. The displacement here is 2, and displacement for the second line is 4. That's the first option. For the second one, fillet, this function is used to smooth the corner with an arc. So we have to define the radius for that arc. Say the radius is 5 units, and then let's go to see the effect of this setting. And now the corner of the rectangle is smoothed with the arc, and the radius is 5 units as what we just said. The last one, width, is used to change the line weight. So if we want to set a specific weight for the rectangle, you need to modify the value of the width. Say the width is 2 units. Then for the rectangle defined, the line width is specified as 2 units. So that's all the properties about the rectangle. In the third example, I will show you how to use the rectangle command to complete this figure. Actually, in this figure, you can find out that the corners of the two rectangles inside and outside are all smoothed with the arcs. So we will introduce the fillet option to complete the joining. In the third example, I will show you how to use the rectangle command to complete this figure. Actually, in this figure, you can find out that the corners of the two rectangles inside and outside are all smoothed with the arcs. So we will introduce the fillet option to complete the joining. Polygon is another commonly applied object in two-dimensional joining. In AutoCAD, you can use the command polygon to generate this type of the figures. You also can go to the toolbar, select joining, and find out the polygon icon to generate a new polygon. Basically, there are 3 different methods for you to develop a new polygon: inscribed, circumscribed, and edges. In the next slides, I'm going to show you how to use these 3 methods to generate a polygon. Now I will show you how to join a polygon with 3 different methods. In this example, I will use these 2 circles to identify the differences of these 3 methods. First, you need to specify the polygon icon in the toolbar or type the command polygon to generate a new one. And in the first step, you need to specify how many number of sides you want to set for that polygon. You can set any number by yourself, for example 7. And then you have to specify the center of the polygon. I'm using the center of this circle as the center of the polygon. The next step is identify the method. We are using the first method, inscribed, and then you choose any point in that circle. Once you click at that point, a polygon will be generated inside of the circle, and all the corners are actually located on the circle. That's the first method. For the second method, circumscribed, still you have to define the number of the sides, the center of the polygon, and specify the method, and choose one point on the circle. And then you will see that the circle is actually tangent to all the sides of the polygon, and actually the circle is inside of the polygon. That's the effect of the second method. And for the third method, edge. In this method, you don't need to specify the center of the polygon. What you need to do is identify one line to represent the direction and dimension of one side. Choose edge here, specify the direction and the length. Once you complete the definition of the direction and the length, you can define one polygon. So those are the 3 methods for the polygons. The last topic in this note is the implementation of points. Actually, in AutoCAD, there are two functions are highly related to points. The first one is the divide command. This command can actually divide one line segment into several shorter segments evenly. And the line could be a straight line, an arc, and even a smooth curve. The second function is measure, and this function will also divide a line segment, but instead of divide the line segment evenly, it will actually split the segments into several shorter segments with the same length. In the next slide, I'm going to show you how to use these two functions. To use divide and measure command, you need first to modify the property of the points. So you have to call the command ddp type and then find out the appropriate type and size for the points. Then let's go to see the divide command. Type divide in the command window and select the object you want to divide, and then you have to enter the number of the segments. Say it's 5. Now the whole line segment is divided into 5 segments with the same length. And then let's go to see the measure command. Choose the object and then specify the length of the segments. Say it's 70. Now the whole line segment is divided into 5 segments. The first 4 segments have the same length, they are all 70, but the last one is much shorter, which is only 10 units. So that's the difference between the divide and the measure. At last, I will show you how to use the divide and arc command to complete the figure in this example. In this demonstration, I will just show you how to draw the arcs in the example. First, we have to use the divide command to divide this line into 3 evenly segments. So at the first step, you need to modify the point type. So use the DDP type, find out the appropriate point style and size. Then we use the divide command and select this line segment. The number of segments should be set as 3. And now you have 2 points marked on the line segment. Next, we have to use the arc command. So here you know the start and end points and also the radius. So you have to use the function start and radius. For the first arc, use the start point, end point, and define the radius as 12. Now you get the first arc. For the second one, use the similar function, start, end, and the radius. And the last one, start, end, and the radius. And then you can remove that line segment, and this will give you the complete arcs to connect these two horizontal lines. That's all about the second note of the fundamental two-dimensional drawings. You can go back to do more practice about the two-dimensional objects learned in this note. In the next lecture, we will finish all the fundamental two-dimensional drawing skills.